from coins to weapons. Tools to ornaments. Metals have played an important role in everyday life from the earliest known times till today. The association of mankind with metals began around 6000 BC when gold, the first metal, was discovered. Gold appears in nature in pure form, and that's why it was easiest for the primitive man to acquire. Stone Age man learned to fashion gold into ornaments. Then another metal was discovered which also exists in nature in the pure form, and this metal was copper. The use of copper in antiquity is of more significance than gold, as the first tools, farming implements, and weapons were made from copper. Copper was so important in shaping the civilization that the time period from 4000 to 2000 BC is commonly called the Copper Age. Then silver was discovered. It was used mainly for utensils and for ornaments. Iron was discovered around 3500 years back. Iron weapons revolutionized warfare, and iron implements did the same for farming. Iron was the building block for civilization, and the time period from around 750 BC to 50 AD is called the Iron Age. An iron pillar dating to 400 AD remains standing today in Delhi, India. Then gradually other metals were discovered. However, till 300 years back, only 12 metals were discovered. Then, in the 18th century, 12 more were discovered. Rest of the metals were discovered during the last 200 years only. In fact, out of the total 114 elements that are known till date, 92 of them are metals, and the rest, only 22, are non-metals. We know that metals have some special properties. All metals are lustrous, that is, they shine and glitter. Some metals can be beaten into thin sheets, even as thin as tissue paper. This property of metals is called malleability. Gold and silver are the most malleable materials. Metals are also ductile, that is, they can be drawn into thin wires. Gold is the most ductile material. In fact, due to these properties, metals can be shaped according to our desire into utensils, ornaments, and tools. Metals are hard, but there are some exceptions also. Some metals like potassium and sodium are soft. We can even cut them with knife. Here I'll take out a piece of sodium coated with paraffin wax, and see, I can cut it with knife. When we cut a piece of sodium metal, the freshly cut piece appears lustrous. Other than being malleable, ductile and hard, metals are also a good conductor of heat. It is for this reason that we use metals for making vessels for cooking. They can absorb heat quickly and aid cooking. Of all the metals, silver is the best conductor of heat. Next best metal is copper. Aluminium is also a good conductor of heat. Obviously, we cannot have silver vessels to cook. Therefore, we have vessels made of copper, aluminium or iron. Another feature of metal that all of us know is that they conduct electric current. Of all the metals, silver and copper are very good conductors of electricity, followed by gold, aluminium and tungsten. But as silver is expensive, we use copper or aluminium wire for electrical works. Metals can be in solid, liquid or gas. In their natural state, all metals are solid. Well, except mercury, which is in the liquid state. It is stated that mercury is the only metal in liquid state. However, as the melting point of cesium is only 21 degrees Celsius, in summers in India, even cesium could be in the liquid state. So is the case of gallium, whose melting point is about 30 degrees Celsius. And now the question arises, where do the metals come from? Metals are actually mined from earth. They usually occur in Earth's crust. These rocky, sandy objects with metals are called minerals. Metals cannot be extracted profitably from all the minerals found in the Earth's crust. Sometimes the amount or the percentage of metals in the compound is so low, or the rocks and the impurities are so high that extracting metals from it would be rather difficult or very expensive. Those minerals from which metals can be profitably extracted are called ores. Most of the metals do not occur in the pure form. They usually occur in the form of a compound, often contaminated with stone and mud. To obtain a metal in pure state from its ore, a process involving several steps is followed. After processing, the metals are obtained in pure form. We know that metals in their pure state have luster. Isn't that so? Then why is it that these metal pieces appear so dull? Let me now scrape off one of the piece and let's see what happens. The sandpaper. Well, now it shines. So why do metals lose their luster? It is due to the reaction that metals undergo when exposed to air. Most metals are very reactive with oxygen in the air and form metal oxide. As a result, they get covered with a thin oxide layer, and this thin oxide layer is the reason for the lusterless appearance. When we scrape this thin oxide layer, the oxide layer gets scraped off. Revealing the lustrous surface. However, gold is a class apart. Do you know that gold hardly reacts with oxygen? As it does not react with oxygen, no oxide is formed. Therefore, it does not lose its characteristic sheen. No wonder it is valued high. We have learned that metals react with various gases in air. Now let us observe how metals react with acids. We have added small amount of metal in each of these test tubes, but not before rubbing it with sandpaper to remove the oxide layer. This test tube has magnesium ribbon. This one has zinc granule. In this we have added iron filings, and in this one there is copper turnings. Now let us add approximately 5 ml of dilute hydrochloric acid in each of these test tubes and observe the reaction. You can see this is magnesium. See how fast the bubbles of hydrogen gas are emerging from it. The test tube also has become very hot. This is zinc, which is not far behind. This is iron. It is also reacting. But what about copper? There is no reaction at all. That means no reaction. When we repeat this experiment with dilute sulfuric acid, we obtain similar results. Do you remember grandma's advice not to keep tamarind, that is imli, in a metal vessel? Do you know why? Because tamarind has tartaric acid in it, and acids react with metals. Most metals react with dilute acids to produce a salt of the metal and hydrogen gas. In fact, most metals also react with water to produce a metal oxide or a metal hydroxide and hydrogen gas. Metals like sodium and potassium react even with cold water, and the reaction is so exothermic that the released hydrogen gas catches fire at once. Some metals like aluminium, zinc and iron do not react with cold water but react with steam. Metals like copper, silver and gold do not react with water at all. Now we know that reactivity of metals with oxygen, acids and water is different. But how do we find that which metal is more reactive than the other? Well, the more reactive metal can displace less reactive metal from its compounds in solution or molten form. Thus, by testing which metal is able to replace the other, we can find the relative reactivities of various metals. This is copper sulfate, a salt of copper, and this is zinc sulfate, a salt of zinc. Let us prepare their solutions in water. Zinc sulfate, water, copper sulfate and water. And now let us stir them to prepare a solution. Zinc sulfate solution. Wash the stirrer before you use it again. So here we have the copper sulfate solution and the zinc sulfate solution. Now we will put some copper turnings into the zinc sulfate solution and some zinc granules into the copper sulfate solution. And let's observe whether some reaction occurs. Observe carefully. The color of the copper sulfate solution has faded away and you can see the deposition of copper at the bottom. This clearly shows that zinc is more reactive than copper, and so it has displaced copper from its solution, whereas copper has not been able to do that. By performing such experiments, the relative reactivities of metals can be found, and the metals have been arranged in the order of their decreasing reactivities. Potassium is most reactive and is followed by sodium, calcium, magnesium and aluminium. Zinc, iron, lead and hydrogen are the next lot. Copper, mercury, silver and gold are at the lowest rung. Actually, even before the relative reactivities of metals were found, people knew that gold, silver and copper are very less reactive. We may think that being strong and powerful is always better, but in case of metals, it is the opposite. A less reactive metal is always more precious. When we think of the word metal, what does come to our mind? An iron tool, a gold, silver or copper coin. But did you know that the salt that we eat, that this pinch of salt also consists of metal? It is sodium chloride, a salt of sodium. The vegetables that we eat are from the plants, the primary producers. But how do plants make their food? By photosynthesis. And how does photosynthesis occur? Due to chlorophyll. Do you know that each cell of chlorophyll consists of one single atom of magnesium? Without the metal magnesium, there would be no chlorophyll, and without chlorophyll, well, no photosynthesis. Do you know that iron forms an important part of our blood? Oh. Now, think of our body. The rigid structure of our body is due to the skeleton, and the skeleton is due to the bones. The bones get their strength from calcium. And what about calcium? It is another metal. In fact, metals give shape and strength not just to our body. Entire modern civilization is dependent upon metals. The Industrial Revolution is thanks to steel. Steel, which is a combination of iron and carbon, with or without other metals like magnesium and so on. The jet age, space age is also due to use of metals like titanium. If the human past is pivoted with metals like copper and iron, it is the metals like uranium, titanium, chromium and magnesium which are paramount in today's economy. As for what metals will become the key part of our life in the days to come, no one knows. But perhaps you will find a new metal scattered on Mars or maybe a moon of Jupiter.